Alright, so multiplying and dividing fractions aren't that bad. However, when we're adding and subtracting, now we're going to go ahead and have to have common denominators because it does involve fractions. So, sounds bad, looks bad. Again, it'll clean up pretty nice. Maybe not as nice as multiplication, but still pretty nice. So, my common denominators should be 3x minus 2 and a quantity of x minus 5. So this particular fraction needs that denominator of x minus 5. So I'm going to have x that's originally there times that x minus 5 over now 3x minus 2 times the quantity of x minus 5 plus the 3 that's already there times what I need on the denominator is 3x minus 2 all over that x minus 5 that's already there times the quantity of 3x minus 2. So the whole reason I do that again is 1 to get common denominators, 2 I have to do the same thing that I do at the top that I do to the bottom because that is technically multiplying by a factor of 1 because anything over itself is 1, even if it's a large quantity. So now that these have common denominators, I can actually combine this into one big fraction, meaning that I can have x times the quantity of x minus 5 plus 3 times the quantity of 3x minus 2 all over this x minus 5 times the quantity of 3x minus 2. Alright, so from here, distribute and combine like terms. So distributing all of that out, I should get something like that. Now I just combine my like terms, and voila, I get this. And now I see, hey, can I factor either the top or the bottom? And I can factor the top not really prettily, so I'd have to use that quadratic formula in the bottom. However, I can factor. So it doesn't really matter. I can't cancel anything. It doesn't make it any prettier, so this step was kind of a waste of time. On to the penultimate question. I've got 2 over x squared minus 2x plus 1 over x minus 3 over x squared minus 4. So what I want to notice here is that I have x squared minus 2x. Those have a greatest common factor that I can factor out. So I've got 2 over x times x minus 2 plus 1 over x minus 3 over, this is a difference of squares, so I can factor that as x minus 2 times x plus 2. So looking for my common denominator now seems a little bit nicer. So my least common denominator should be, well, got an x in these two, but not in that one, so that's not common among them. I've got an x minus 2 in these two, but not in that one, so that's not common among all 3 of them. And then finally, I've got an x plus 2 over here that isn't in any of the rest of them. So there's my least common denominator. There's what I need to have in all 3 fractions. So looking at that first one, I don't have an x plus 2, so I need to do that. Looking at the second fraction, I don't have that x minus 2 or x plus 2, so I need to multiply the top and bottom by both of those. And then finally, on this last one, I just don't have that x out in front that I need to multiply by, so I need to fix that up. So doing this, I can just make it one big fraction, and I can distribute up top. So, one big fraction, I'd get x times x minus 2 times x plus 2 on bottom, all over. The first part should be 2x plus 4. Second part should be x squared minus 4 minus 3x, all in all. Alright, now I'm going to combine my like terms, maybe distribute that bottom out. Okay, so I said maybe distribute that bottom out because, well, I might not have to refactor it out if I don't have to. because I'm looking up top and I'm saying, okay, I've got a greatest common factor of an x up here, so let me factor that out. Alright, so factoring that out, I should see that my x and my x cancel out, leaving me with just x minus 1 over x minus 2 quantity times the quantity of x plus 2. So altogether now, distributing this out, I should just get x minus 1 over x squared minus 4. Alright, that problem's done.